Hello dear students, welcome to one short series of industrial engineering for GATE 2023. And today we are going to discuss project management. Because GATE exams is hardly 1.5 months apart. And in this one short series, what exactly I'm doing, because already you don't have time. So in short, entire topic can be covered, and some of the important questions by which your fundamentals are clear, I'm taking up those points. I'm not wasting any time just to stretch the lecture and so on. Okay, now? So let us discuss the project management in this particular lecture. This is the 6th lecture. This is our team Drona. As I tell in every lecture, it is not the work of one person. There is a team. There is a very expert team. So what I am going to discuss in this particular lecture, I will discuss something about the precedence diagram, critical path method, then I will discuss crashing of network, and then I will discuss PERT, program evaluation and review technique, PERT. The difference between critical path method and PERT is, critical path method is a deterministic model. Deterministic model means suppose any activity is happening, all its time can be predicted. Suppose truck goes from Hyderabad to, let us say, Karimnagar. Its time is fixed. 6 hours 20 minutes fixed. So it's an activity. When the truck goes from Hyderabad to Karimnagar, it's an activity and its time is fixed. Then we will go for critical path method, CPM. But when there are probabilities, suppose a truck goes from Hyderabad to Karimnagar, it may come in 4 hours, it may come in 16 hours, but most likely it comes in 6 hours. So there are 3 times, because the activity times follows a probability distribution. So when the probabilities are given, we follow PERT. I am going to discuss in detail about PERT after approximately 1.5 hours. So CPM is deterministic approach and PERT is the probabilistic approach. Okay, now these are my credentials. I am gold medalist in BTech from AMU, Aligarh Muslim University, because I was a university topper. I am MTech and PhD from IIT Delhi, and between MTech and PhD I worked for engineering services for approximately 1.5 years. Presently I am a researcher. I research in material characterization and metal forming. And as per Scuba's data, I am top 5% researcher in the world. Now, first of all, let us discuss, there are some rules to construct precedence diagram. To construct precedence diagram. Precedence diagram. This precedence diagram is, suppose there is a construction of building. Some building we would like to construct. There are different activity. First activity, let us say digging the foundation. For some excavator comes, digs the foundation. It's an activity. Then the construction people will come to lay the foundation. Then slab is another activity. Construction of wall, another activity. After that activity, there will be cementing of wall. After that, painting. So painting is a successor activity. Cementing the wall is a predecessor activity. Understood what is the meaning of predecessor and successor? Successor means the activity comes after that. Cementing the wall is a predecessor activity. Painting the wall becomes the successor activity because you cannot paint the wall before cementing. So now for any project, because I will give some live example. Construction of building is a very beautiful example of to understand CPM and PERT. Okay, so the same example I will keep on giving. I will not change the example because it's a one-shot crash course and my logo is not to waste your time. In a crisp way, everything can be delivered to you. That is my target. So same construction example I will be keep on giving. So now, from starting of any project to the close of any project, there are multiple activities. And when those activities are presented in the form of a diagram, like predecessor and successor, that diagram is called a precedence diagram. The diagram is called a precedence diagram. Now, for constructing the precedence diagram, there are some rules. Constructing the precedence diagram, there are some rules. Rule number 1, project start or project completion is to be considered as the only one event. Only one event in time. Suppose there is one activity consumes Tij time and it is going from ith node to jth node. This is called node and this is called branch. Ith node, jth node, and this is the branch. Generally in your competitive examination there is activities on branch only. In the competitive examination syllabus there is activity on branch only. But if you go for higher education, let us say MTech or MS, there is something called activity on node also. But activity on node we will not touch it in these lectures because we are preparing for competitive examination. So there is an activity on branch and activity consumes some time. And the node is one time in space. For example, 20th November 10:30 AM. It's a node. It's an event. It's not activity. Event is some time in space. Or let us say 25th December 11:05 AM. Activity will start. It's a node and it's a time in space. So understand what is a node? Node event doesn't consume time. Activity consumes time. So on the node there will be event. On branch there will be an activity. On node there will be event and activity will be on the branch. For all competitive examinations, activity is always on branch. Okay. Now let us say what are the rules. What are the rules of constructing a precedence diagram? Precedence diagram is a sequence of predecessor and successor activity, represents the entire project. Okay. So now project start or project completion is to be considered as the only one time event, and project start is a burst node. This is called burst node, means multiple activity starts from single node. You cannot do like this. Like project start cannot be multiple event. Project start will be a single event. project start will be a single event, so project start will be a burst node. Project start will be a burst node. Burst node means multiple activity start from the same node. Similarly, the project completion will be a converging node. Project completion will be a converging node. You cannot have multiple events for the project completion like this. You cannot have multiple events for the project completion. So project start and the project completion will be a single node. Project start and the project completion will be a single node. So project start will be a burst node and the project completion will be a converging node. That is the first rule. You cannot hang the activity in a space. You cannot hang the activity in a space. So this is your first rule of constructing the precedence diagram. Once again, any doubt you have, you can direct all your doubt to me. Many students from PW family, they are asking many doubts to me. So you are also welcome. Now, second is, while constructing the diagram, different activities should not cross each other. I mean, diagram like this should not appear. Activities cannot cross. Activities cannot cross each other. I will give you one funda based on my experience. Suppose the sequence of predecessor and successor activities are given to you. Sequence of predecessor and successor activities are given to you. So you know what will happen? When you are constructing, most of the rules will be violated. Initially, when we are constructing, most of the rules will be violated, including crossing the activities. So what do? You update it. You update it. In the exam, you construct the precedence diagram with the pencil and then remove it again, join it. Final diagram you should draw it neatly. This particular lecture will also be beneficial for university examination, our students. So I'm telling them, initial precedence diagram should be drawn with the pencil. There will be many mistakes. You update it. So in the final precedence diagram, activities cannot cross each other. Activities cannot cross each other. Rule number 3. More than one activity cannot start at the same node and also finishes at the same node, like this. You cannot have this arrangement. You cannot have this arrangement that there are two activities starting from the same node and finishing at the another node. If such a situation arises, use dummy. If such a situation arises, use dummy. And what is the dummy? Like this. If such a situation arises, use dummy. How to use dummy? Like this. First activity, use dummy. Let us say 1, 2, 3, and then joining like this. Two activities cannot start at the same node and cannot finish at the same node. And if such a situation arises, use dummy. Now, dummy activities do not consume any time and are used just to complete the precedence diagram. Dummy activities, they do not consume any time. Dummy activities are used just to complete the precedence. Dummy activities are used just to complete the precedence. Okay, now please remember that. Dummy activities are used only in case of absolute necessity. Minimum number of dummy activities must be used. Minimum number of dummy activities must be used. Now, while constructing the precedence diagram, Let us say only one dummy activity is sufficient, but you have used two. So while refining the precedence diagram, you delete one. While defining the precedence diagram, you delete one. So minimum number of dummy activities should be used to construct any precedence diagram. Minimum number of dummy activities should be used to construct any precedence diagram. Now next rule is time always flows from left to right. Meaning time is always, because this is my left, this is the right. So time is always flowing from left to right. This is not permitted. This is not permitted. Time cannot flow from right to left. Time cannot flow from right to left. Please remember that. Okay, while giving the final precedence diagram, time cannot flow from right to left. All nodes with the exception of the terminal node must have at least one successor. Unless and until it is the finishing node. Like this, the finishing node. Unless and until it is the finishing node, all other nodes will have a successor event. Unless and until it is a terminating node. Terminating node means the last node. That node will have a successor. Will have a successor, okay? An arrow specify all node except the first must have at least one predecessor. So there is no activity before the burst node or starting node. It's the project start. And this is the project finish. So there is no predecessor before that, and there is no successor after that. But in between, there will be predecessor and successor. Successor means after that. Predecessor means before me. Okay? So that is the meaning. An arrow specifies only precedence relationship. Its length has no significance. For example, let us say I say like this or like this. It is not geometry that large arrow will consume more time. No. Arrows are used just to complete the precedence. It has no significance related to the quantity. Let us say it's a 2 minute, it's a 8 minute. No. It is not correct. It is not correct. Arrow do not signify the quantity. Okay, na? So you have to remember that arrow doesn't signify anything. Cycle or closed loop paths through the network are not permitted. This will form a closed loop, see? This will form a closed loop. These things are not allowed. So time cannot flow from right to left. So anyway, these are some of the important rules that we have to follow in constructing the precedence diagram. So based on these rules, you may find questions in objective. Because my target is GATE 2023. While recording these one shot, my target is GATE 2003. See, one thing you should remember, critical path method is a deterministic model. It is activity oriented. It is activity oriented. Because while solving the problem, activity is in the focus. Part is the probabilistic model and it's a event oriented. Means node and this means branch. This means branch. Critical path method is activity oriented, means branch oriented, because in your syllabus activities are always on branch. Part is event oriented, means a node. So now, till now we have discussed what are the rules that we have to follow while constructing the precedence diagram. We will solve a simple problem. This is the problem. Draw the precedence diagram for the following data. Draw the precedence diagram for the following data. So I am discussing only few problems so that we can hit the bull's eye. I don't want to waste your time in one short series, okay? Because already GATE exam is on our head. So in a capsule form, I will teach you everything so that you can hit every single problem in GATE 2023. So activity A and B, they do not have any predecessor. And whenever there is a question, I will be a little slow so that in your pen and paper you can also start solving, because unless and until you struggle you will not learn. Unless and until you struggle you will not learn. So activity A and B, there is no predecessor. It means it will be a burst node. This is activity A, activity B. So only starting node will not have any predecessor. So both these activities will start from the start node. That is the indication, okay? So the way the data is given, accordingly I will be keep on moving, okay? Activity C predecessor is A. Activity C predecessor is A, correct na? See, on the precedence diagram I have shown. Activity D predecessor is B. But now activity E predecessor is C and D. So that is possible only when it is merged in the same node. Understand? Na? Initially I have drawn like this, but seeing the next successor activity, I have merged this activity in the same node. Suppose it's a regular class, we would have practiced many problems to make you understand how exactly it happens, and if it's a live class we would have seen your chat. But unfortunately we don't have time. One short capsule, we have to give everything to you. So E and F, both C and D are predecessor. E and F, both C and D are predecessor. For G, predecessor is E. G predecessor is same situation like this will happen there. H predecessor is F, and I predecessor is GH. So I predecessor is GH. After constructing this, you draw the number 1, 2, 3, 4. See, time cannot flow backward, meaning I cannot do like this. That is not allowed. Time cannot flow from right to left. So 3, 4, this I cannot do. So 3, 4, 5, 6, 7, 8. Time always flows from left to right. Time always flows from this is the left and this is the right. Time always flows from left to right. Time always flows from left to right. My precedence should be correct. Okay, my precedence should be correct. So for constructing the precedence diagram, I have taken up only one problem. Once again, line balancing, these things are not in the GATE syllabus. In engineering services, it is there. So if it is IES crash course, I would have covered line balancing and all these things. Unnecessary, do not want to waste your time. Line balancing is not in GATE syllabus. Prior to 2015, it was there, but not anymore. So constructing the precedence diagram. Now, let us go for critical path method, CPM. Let us go for critical path method, CPM. Critical path method. CPM. I will go a little slow. So you should be very prompt in your pen and paper. Question is, draw the network diagram for the given project and show critical path, and also calculate the total project duration and the floats. Total project duration and the floats. In your competitive examination, whatever I am going to teach you in the next half an hour, it is very, very important. Whatever I am going to teach you for next half an hour in this one shot series, it is the most important section. So please pay very careful attention, okay? Because question ask about calculating the float. What is the meaning of the float? Lot of objective questions can be formed on that. So with the help of this question, I will teach you everything. Weight, let us say weight is in days. Activity 1 to 2 consume 2 unit time. Activity 1 to 3 consumes 8 days. Like this unit means I'm considering days. In the previous problem, predecessor and the successor was given to you. In the previous problem, predecessor and the successor was given to you, but here nodal position is given. But here nodal position is given to you. Previously predecessor and successor was given, but here nodal position is given to you. So when the nodal position is given to you, construction of precedence diagram is extremely easy. When the nodal position is given to you, construction of precedence diagram is very easy. So 1 to 2, and 1 to 3. 1 to 2 consume 2 unit time. 1 to 3 8 unit time. 2 unit time, 8 unit time. Okay. 2 to 4 and 2 to 4 and 3 to 4. 2 to 4, 3 to 4. Because the nodal position is given to me, construction of precedence diagram is very, very easy. 2 to 4, 4 unit, 3 to 4, 1 unit. That's what we have done. 3 to 5 and 4 to 6. 3 to 5 and 4 to 6. 3 to 5 2 unit, 3 to 5 2 unit, 4 to 6 5 unit, and finally 5 to 6 is 6 unit. 5 to 6 is 6 unit. So our precedence diagram is drawn. When the nodal position is given to you, construction of precedence diagram is extremely easy. But when the predecessor and successor events are given to you, we have to apply mind to construct the precedence diagram. We have to apply mind to construct the precedence diagram. Okay. Now we are discussing critical path method, CPM, because all the activity times are deterministic. All the activity times are deterministic. It's a critical path method. Okay. Now, you know what is my next step? At each and every node, make this kind of box. At each and every node, make this type of box. Okay, now generally what is happening, many people, those who are the online system, they are wasting a lot of time. The things that can be explained in 1 hour, they are taking 3 or 4 hours. I don't know why. If it is a live class or offline, I do recommend basically to take care of all the students, but it's a recorded one. Everything is available on the YouTube free. If you want to repeat, students themselves can do it, because for the benefit of students, we should not keep on extending the topic beyond the limit. But if it's a live class, I do agree, we have to repeat. We have to see the student how they are doing, or if it's an offline class, we have to see that. But recorded one, I don't feel any sense, because if it is a 6-hour lecture, who will have patience to see it? So that is the reason in industrial one shot, I am giving everything very compact. If you wish to see, you can see it again. Okay. Now make this box. Now I'm doing the forward pass. I'm doing the forward pass. Forward pass means from here I'm going to this side. Project start 0. 0 time is spent. So forward pass. In the forward pass, I will write the value in the first box. In the forward pass, I will write the value in the first box. So 0 plus 2, 2. 0 plus 8, 8. I am doing the forward pass. Okay, na? 8 plus 1, 9. 2 plus 4, 6. In the forward pass, I take the maximum value. In the forward pass, I take the maximum value. So 8 plus 1 is 9. 2 plus 4 is 6. So I will take 9 because 9 is higher. 8 plus 2 is 10. 10 plus 6 is 16. 9 plus 5 is 14. I will take the higher one, 16. So this is my forward pass. I am going from the left hand side to right hand side. It is called forward pass. Now, whatever is there in the last bracket, same value you write it here. Same value you write it here. Okay. Now do backward pass. Now do backward pass. In the backward pass, I am going from right hand side to left hand side. I am going from right hand side to left hand side. 16 minus 6 is 10. I am subtracting the values in the backward pass. 16 minus 5 is 11. 16 minus 5 is 11. 11 minus 1 is 10. 10 minus 2 is 8. 8, 11 minus 1 is 10. In the backward pass, I will take the minimum value. I will take the minimum value. So 10 minus 2 is 8. 11 minus 1 is 10. So I will take minimum value 8. 11 minus 4 is 7. 7 minus 2 is 5. 8 minus 8 is 0. So understood how to do forward pass and backward pass? I hope everybody understood that how to do the forward pass and the backward pass. Once again, because the recorded lectures, everything is available on YouTube. So if you want to see it again, do the backward and forward. It will be easy for you. Many times you can see. Okay, na? During the lecture, I don't have to repeat. But if you want to hear some concept again reverse it. This is called project completion time. Project completion time is 16 days. Project completion time is 16 days. Now suppose, see this activity 4 to 6. Consumes 5 days. Nine, 11, 16, 16. Let us say this is ith node, this is the jth node. Now I am generalizing the thing, ith node and jth node. Tij is the time consumed by activity going from ith node to jth node. Tij is the time consumed by activity going from ith node to jth node, and it is 5 minutes. Okay, na? Whatever is written in the box, it is ei, li. L means latest, I means, and E means earliest, L means latest. This is ei, earliest of ith node, latest of ith node. Okay, earliest of jth node, latest of jth node. I'm generalizing the thing. Okay, na? I'm generalizing the thing. I have taken activity 4 to 6, and this is the generalization. My activity is Tij. This EI is earliest start time. Earliest start time of activity Tij. Here all of you have to be very, very careful. Some of you may be thinking that I know these things very well, but there is a googly. So everybody should hear very, very carefully. In GATE and any competitive examination, lot of question comes from this section, and lot of students are having many confusions. So please hear very carefully. Whatever is written here, it is the earliest start time of this activity. Earliest start time of this activity. This is the latest finish time. Latest finish time of activity Tij. This is the latest finish time of this activity. This is the earliest start time of this activity. Now, what many students do, many students, based on my 23 years of teaching experience, I started in year 2000 teaching to competitive examination. They say earliest finish time, latest start time, earlier finish time. No. 11 and 16, they are not latest finish time and latest start time. No, it is not like that. It is a different thing. Earliest start time, earliest finish time will be earliest start time plus Tij, meaning earliest start time is 9, Tij is 5. So 14 will be the earliest finish time of activity Tij. That way we do it. This is the earliest start time, this is the latest finish time. So latest start time is latest finish time minus Tij. Latest start time is the latest finish time minus Tij. Means 16 minus 5 is 11. It's a coincidence that these figures are matching, but it may not match. It may not match. Okay, it may not match. So how to find out the latest start time? Latest finish time minus Tij. How to find out the earliest finish time? Earliest start time plus Tij. That way we calculate. So our head should be very cool while calculating all these things. Our head should be extremely cool while doing all these things. Okay, our head should be super cool while doing all these things. Okay, so let us calculate earliest start time, latest start time, earliest finish time, and the latest finish time for all these activities. Let us calculate that. So what I recommend that you draw these things in your notebook. See, most of these problems I am taking from my book. Previously there was some other publisher who used to publish my book, but in February Narosa publication will publish my same book. Okay, because there was some clash of interest. Everybody is a good person only, but clash of interest sometimes happens. So Narosa has taken the copyright and they will publish my industrial engineering book. I'm clubbing with my friend Professor Anand Pare of IIT Indore. He's a professor, close friend of mine. So both of us will write the second edition of this book. February it will appear in the market after gate. Okay. So I'm having all this data. We will calculate earliest start time, latest start time, earliest finish time, and latest finish time for all these activities. Okay. So let us do it. Activity 1 to 2. Activity 1 to 2. This is the earliest start and this is the latest. Earliest start is 0. And the latest finish time is 7. Latest finish time is 7. Correct? Activity consumes 2 unit time. So earliest finished is earliest start plus Tij. Earliest finish is 2. 0 plus 2 is 2. Latest start is 7 minus 2. Correct, na? Latest start time is latest finish time minus Tij. Tij is 2. Correct, na? Now activity 1 to 3. Activity 1 to 3. Earliest start is 0. Latest finish is 8. Earliest start is 0. Latest finish it is 8. All of you should do with me. Okay, na? Then only there will be learning process. If you do with me, learning process will be very good. Earliest finish time means 0 plus 8. Latest start is 8 minus 8. Correct? See activity 2 to 4. 2 to 4. Earliest start is 2. Latest finish is 11. You can also verify with your precedence diagram because my precedence diagram is 2 slides before. Earliest finish time means earliest start time plus Tij. 6. Correct? Latest start time means latest finish time minus Tij. So 11 minus 4 is 7. I hope everybody is doing well. Activity 3 to 4. Activity 3 to 4. Earliest start is 8. Latest finish is 11. I am basically applying these two formulas. I am applying these two formulas everywhere. Earliest finish time is EST plus 1 because this is Tij. Correct, na? It's a Tij. Latest start time is 11 minus 1, 10. Correct? 3 to 5. Earliest start is 8. Latest finish is 10. Earliest finish time is 8 plus 2, 10. Latest start time is 10 minus 2, 8. Exactly the same thing I am doing as a matter of practice. Okay, na? As I told you, These discussions are extremely important. Please be careful. These discussions are extremely important. 4 to 6. 4 to 6. EST is 9. LFT is 16. EFT is 9 plus 5, 14. And LST, 16 minus 5 is 11. Last activity is a 5 to 6. 5 to 6, 10 and 16. 10 and 16. So EFT is 10 plus 6 is 16. LST is 16 minus 6, 10. So we have calculated the EST, EFT, LST, LFT for each and every activity. We have calculated that. Okay, now we have calculated. I will be dead slow. I humbly request to all the students, those who are watching this video, that now they should be super attentive for next 15 minutes. They should be super attentive for next 15 minutes, because whatever I am going to teach you, you cannot learn from the books. Whatever I am teaching you, you cannot learn from the books. Only a teacher has to teach you. Only a teacher has to teach you these things. You cannot learn from the books. And many question comes in objective. And the good thing about whatever I am teaching today, that variety is not possible. Whatever fundamentals I am teaching you, fundamental remains same, and even the variety is also not possible. So once everything goes to your mind, every single problem you will be able to hit. So once again, I want your absolute attention for the next 15 minutes. Absolute attention for next 15 minutes. Let us calculate total float. First of all, we will calculate total float. Then I will explain to you one by one. I will explain about each and every float after calculating it. Okay. Total float is this one. Of course, these things will be given to you, so you don't have to worry. All the slides will be given to you. Total float is LST minus EST or LFT minus EFT. Meaning, either you subtract this from this or this from this. LST minus EST or LFT minus EFT. So you can choose to do anything. 5 minus 0 is 5. Oh, it's not visible, so I will choose a different color. I will choose a different color. This is correct on this. Okay, na? 5. 0 minus 0 or 8 minus 8 remains 0. 7 minus 2 is 5. Or 11 minus 6 is also 5. 10 minus 8, 2. 8 minus 8, 0. 11 minus 9 is 2. 10 minus 10 is 0. So these are the values of total float. These are the values of total float. See, what this total float what information this total float gives you. What information this total float gives you. It is the extra time available without affecting the project completion. It is the extra time available with an activity without affecting the project completion. Okay. Now, see what are the activities having zero float? 1 to 3, 3 to 5, 1 to 3, 3 to 5, and the 5 to 6 are having zero float. Zero total float means zero total float means there is no surplus time available on that activity. Zero total float means there is no surplus time available on that activity, and any amount of delay on that activity, any amount of delay of that activity will affect the project completion. Any amount of delay of that activity will affect the project completion time. So on the critical activity, we have to have a very close supervision. We cannot afford to have any delay on those critical activities. So what are the critical activities? 1 to 3, 3 to 5, 5 to 6 are called critical activity. Critical activities will have a zero total float. Critical activities will have a zero total float. And on the critical activity, very close supervision is required, because any amount of delay of that activity will affect the project completion time. Presently, the project completion time is 16 days. But suppose any critical activity is delayed, project completion time will increase. So very close supervision is required on the critical activities. Now, let us say activity 1 to 2, the total float is 5. Activity 1 to 2, total float is 5. Activity 1 to 2, the total float is 5. You know what is the physical meaning of this information? What is the physical meaning of this information? This activity 1 to 2, 5 days surplus amount, 5 days surplus time is available with this activity 1 to 2. 5 days surplus time is available with this activity 1 to 2. So due to some problem in the project, if the activity 1 to 2 is delayed by even by 5 days, due to some problem in the project, if the activity 1 to 2 is delayed by 5 days, still there will not be any change in the project completion time. Project will be completed on time. Project will be completed on time. So understood? Total float is extra time available on any activity that if that particular activity is delayed within that time period, project completion time will not change. Total float. Total float is good, correct? Na? So we have discussed the total float. What exactly is the total float we have discussed? Now, free float. So what is a free float? While going for forward pass and backward pass, These are the values written, and I have already told you this is the earliest start time and this is the latest finish time. And 𝐸𝐽 and Li refers to the node, not the activity. To calculate earliest finish time, EI plus Tij. That's the way we do it. We have done a lot of calculations till now. So free float is, if you are calculating free float of any activity, let us say this particular activity, so 𝐸𝐽 minus EI, free float of this activity is 𝐸𝐽 minus EI minus Tij. This minus Tij will be the free float of that particular activity. So first of all, we will calculate the free float of each and every activity, then I will elaborate on it. Free float. Free float of activity 1 to 2. Now, 𝐸𝐽 minus EI minus Tij is the free float. Activity 1 2. 𝐸𝐽 minus EI minus Tij. 𝐸𝐽 minus EI minus Tij. 2 minus 0 minus 2 is 0. It is visible, yeah, it is visible. Now activity 1 2 3. Activity 1 2 3. 𝐸𝐽 minus EI minus Tij. 8 minus 0 minus 8 is again 0. Activity 2 to 4. Activity 2 to 4. 𝐸𝐽 minus EI minus Tij. 9 minus 2 minus 4. 3. Okay. Activity 3 to 4. 9 minus 8 minus 1. 𝐸𝐽 minus EI minus Tij. 9 minus 8 minus 1 is again 0. Activity 3 to 5. 10 minus 8 minus 2. 𝐸𝐽 minus EI minus Tij. So again it's 0. Activity 4 to 6. 𝐸𝐽 minus EI minus Tij. 16 minus 9 minus 5 is 2. And activity 5 to 6. 𝐸𝐽 minus EI minus Tij is again 0. So this is the free float. We have calculated the free float. Now, what is the free float? It is the extra time available with an activity. It is the extra time available with any activity without affecting any of the successor activity. Without affecting any of the successor activity. I will give you one example. I told you in the beginning that I will give the example of construction of the building. So let us say the project is the construction of this building. painting is a successor activity and the cementing the wall is a predecessor activity. I told you this thing before. Cementing the wall is a predecessor activity and painting the wall is a successor activity. I told you. Now, hear very carefully what I'm saying. Cementing the wall is a predecessor activity. Painting is a successor activity. Let us say the activity of cementing the wall, there is a free float of 3 days. There is a free float of 3 days. So what exactly happened that some of you may become managers later on, managing the project. You will realize that dealing with the worker is not easy at all easy. Dealing with the worker is not at all easy. During the third year of my engineering, I did training in one very big company. I will not tell the company name because it is going live and it is YouTube available, because I am really careful not to hurt anybody. And I did training in one company, and the engineer, workshop engineer, he was the most exploited person. These workers, those who are ITIs, they used to shout at him, and one person punched basically the engineer, because engineers was trying to correct them because they have union. So the engineer cannot do anything. So fight between the worker always happens. So let us say cementing the wall is an activity where there is a free float of 3 days. Successor activity is a painting, and there is a different set of people, they will come for painting. Now, what exactly happened during cementing? There was a fight between the workers, and the fight was so heavy, then there was a fracture, 3-4 fractures among the people. Fight was very heavy, and there was fracture. If the project manager working on the site, if he manages the activity within 3 days delay, paint people will not come to know that there was some issue on the site, because they will come as per their schedule. Project manager will hire some people, okay, you take rest, and somehow you managed the cementing the activities within 3 days delay time. So the painting people will not come to know that what was the problem on the site. But suppose he is not able to complete within 3 days delay, he completes in 4 days. Now, when the activity delay goes beyond the free float time, successor activity will come to know that there was a problem in the site. Painting people will come as per the schedule, but cementing is not over. So painting people will say, oh, what was the problem? They will inquire. They will come to know, oh, there was a fight. Oh, there was a fight on the site. They will come to know. Still project may not delay. Because painting people will have their own float. So project can be completed on time, because the successor activity will also have a float. Now understand what is a free float? Free float is extra time available with any activity without affecting its successor. Extra time available with an activity without affecting the successor. Cementing is a predecessor activity. Painting is a successor activity. Cementing, there is a 3 days float. If the cementing activity delays more than 3 days, it will affect the painting schedule. But if the delay is less than 3 days, painting will be as per their schedule. So that is free float. Free float is the extra time available with an activity without affecting any of the successor, without affecting the successor activity. So I have elaborately discussed with you the total float and the free float, correct? Now, third is a safety float. Safety float is Lj minus Li minus Tij. Same this activity, Lj minus Li minus Tij will be the safety float. Lj minus Li minus Tij is the safety float. So let us calculate safety float for all those activities one by one. See, I told you, you have to be very, very attentive. Huh? If you are attentive, everything will be crystal clear in your mind. So activity 1 to 2. Activity 1 to 2. Lj minus Li minus Tij. Lj minus Li minus Tij. So 7 minus 0 minus 2 is 5. Safety float is 5. Safety float is 5. Activity 1, 2, 3. 8 minus 0 minus 8. Lj minus Li minus Tij. So again, it's 0. Activity 2 to 4. 2 to 4. 11 minus 7 minus 4. 11 minus 7 minus 4 is again 0. Activity 3 to 4. Activity 3 to 4. Lj minus Li minus Tij. Lj minus Li minus Tij. 11 minus 8 minus 1. 2. 3 to 5. 3 to 5. Lj minus Li minus Tij. 10 minus 8 minus 2 is again 0. 4 to 6. 4 to 6. Lj minus Li minus Tij. 16 minus 11 minus 5 is again 0. And 5 to 6. 16 minus 10 minus 6 is again 0. So these are the values of the safety float. Understood how to calculate the safety float? And this is the safety float. Safety float is extra time for available extra time for starting activity Tij beyond LST of ith node. Ith node, what is the latest start time? Latest finish time minus Tij is the latest start time, correct? Huh? So extra time available for any activity Tij beyond LST of ith node. This is the LST of ith node without affecting the LST of jth node, because there will be some successor activity. By that, LST of the jth node will come. There will be a successor activity from, because this is the activity by which I am calculating the LST of ith node. There will be some successor activity for this. By that, I will calculate the LST of jth node. So what is the extra time available with an activity without affecting LST of the jth node? Is called safety float. Is called safety float. Now, last one is an independent float. See, these things are very, very important. Unless until you cannot mug up these things. Some teachers also say mug up, mug up, mug up. By mugging up, you know, we will not be able to remember an exam. Mugging up is very bad for cracking the exam. 10% cases we have to mug up, but 90% we have to have fundamentals. Now, independent float. ej minus li minus tij. ej minus li. ej minus li minus tij. ej minus li minus tij is independent float. And this is safety float. So now 1 to 2, activity 1 to 2, ej minus li minus tij, ej minus li minus tij, 2 minus 0 minus 2 is 0. Independent float I am calculating. And the independent float is ej minus li minus tij. Okay, na? Now activity 1 to 3. Activity 1 to 3. ej minus li minus tij. Again 0. Activity 2 to 4. Activity 2 to 4. ej minus li minus tij. 9 minus 7 minus 4, it's minus 2. These floats can be negative. Remember, floats can be negative. 3 to 4. ej minus li minus tij, 0. 3 to 4. ej minus li minus tij, 3 to 4. 3 to 5, sorry. Now 3 to 5. ej minus li minus tij is again 0. 4 to 6. 4 to 6. ej minus li minus tij is again 0. 5 to 6. ej minus li minus tij is again 0. So these are the independent floats. So now my table is complete now. My table is complete. Check whether is there any issue with that. My table is complete now. Okay. What is exactly the independent float? Extra time available without affecting any of the earliest and latest times. Independent float is the extra time available with any activity. Independent float is the extra time available with any activity without affecting any of the earliest and latest time, of any of the successor activity. Any of the earliest and latest time of any of the successor activity. is called independent float. And there is a relationship between these four floats. There is a relationship between these four floats. Relationship between these four floats. Okay. So whatever I discussed in the last 15 minutes, you will find many questions in objective examinations. So that is the reason I told you to be bit careful. That's the reason I told you to be bit careful. This is the next problem of crashing. Crashing of networks. In the given project, what will be the cost of total project when its duration has to be decreased by 4 days and 10 days respectively? Again, it's a very important discussion that we are going to do. What is exactly crashing? Any activity any activity's duration can be decreased by providing them additional facility. For example, again, construction of the building. Let us say cementing the work. Cementing the whole building. Usually it takes, let us say, 10 days. But I can accelerate it to 5 days by employing additional manpower. This is called crashing. Crashing means decreasing the duration of any activity by providing additional facilities to the activity. And when we provide additional facility, it incurs certain cost. So the cost of the project will increase, but its duration will decrease. Again, there are two types of cost, direct cost or indirect cost. So we have to compromise on that. I will tell you one story. In the North India, there is one university. I will not tell the university name, because again it's freely available on YouTube. Because I don't know who will take the message in what sense. Generally, when the controversy arises, the intention of teacher is not to get into any controversy. But there are always so many scrupulous people. They try to screw different type of meaning by cutting and all these things. That is the reason I'm not telling the name. So when that university started, there was no building. But they have got permission from AICT somehow. So when the fees was collected, then they constructed one building. Because at the time of depositing the fee till the class work commences, there is a lot of time. So certainly the activities were crashed to construct that building. So every year by year, they started constructing the newer and newer building, again without investing anything additional. Whatever fees they used to collect, they used to construct one building. And now presently it's one of the biggest university in North India. How they could do it? By crashing. Whatever activity that can be done, let us say in 6 months, they crashed it to 2 months. So that is called crashing. Decreasing the activity duration by providing them additional facility. For example, activity 1 to 2 can be completed in 20 days. Activity 1 to 2 can be completed in 20 days, but it can be crashed to 17 days. It means 3 days crashing is possible. Normally, activity consumes 600 rupees, but 3 days crashing, it will cost 720 rupees. I mean, 120 rupees additional you have to pay for 3 days crashing. 120 rupees additional you have to pay for 3 days crashing. It's a 3-day crashing, na? 20 to 7. So we are increasing the project cost by crashing, but the project duration will decrease. But because I'm not touching the aspect of direct cost and indirect cost, because it will be too much for gate. The machine specific activities cannot be crashed. See this one. This activity cannot be crashed. What activities cannot be crashed? Machine specific. Because you cannot purchase another machine and put it there, na? So machine specific activities cannot be crashed. So activity 1, 2, 3 is a machine specific activity. Rest of the other activities can be crashed. So normal time, crash time, normal cost, crash cost. So this matrix is given to you. So now the question question is asking, what is the normal project completion time? How much will be the normal project cost? How much will be cost if my project duration is decreased by 4 days and 10 days respectively? So there are 3 questions inbuilt into it. There are 3 questions inbuilt into it. So before starting solving this any problem, we have to draw the precedence diagram. And the nodal position is given to you. Nodal position is given to you. So construction of precedence diagram will be very easy. So let us draw the precedence diagram. One to two, and 1 to 3. 1 to 2, 20 days and 25 days. I will write only the normal time. I will write only the normal time. How to handle the crash times, I will tell you. Okay, how to handle the crash times, I will tell you. 2 to 3, 1 to 2, 1 to 3. Now 2 to 3, 2 to 3. It takes 10 days. 2 to 3 takes 10 days. 2 to 4 and 3 to 4. 2 to 4 and 3 to 4. 2 to 4, 12 days. 4 to 5 and 4 to 6. 4 to 5, 10 days. 4 to 6, 5 days. 5 to 7, 6 to 7. 10 days and 8 days. So now we have constructed the precedence diagram the way we have done previously. We have constructed the precedence diagram. Now do the forward and backward pass. Do the forward and backward pass. So 0, 0 plus 20, 20, 20 plus 10, 30, 0 plus 25, 25. In the forward pass, I take the maximum value. 30 plus 5, 35. 20 plus 12, 32. 35. Because in the forward pass, I take the maximum value. 35 plus 10, 45. 35 plus 5, 40. 45 plus 10, 55. Because 40 plus 8, 48. So we will take the maximum value. So here 55 and here 55. So project completion time is a 55 days. Project completion time is 55 days. Now go for the backward pass. 55 minus 10, 45. 55 minus 8, 47. 47 minus 5, 42. 45 minus 10, 35. In the backward pass, I take the minimum value. 35 minus 5, 30. 30 minus 10, 20. 35 minus 12. So we will take the minimum 20. 30 minus 25, 5. 20 minus 20 is 20. So now the forward pass and backward pass. Now our procedure will be more or less same. There are 4 floats, but in this problem we will not calculate all the 4 floats. We will calculate only the total float. Because in handling the crashing problem, we need only the total float. In handling the problems of crashing, we need only the total float. So we will calculate total float in this case. The same matrix I have drawn again. What is cost slope? You wait for some time. First of all, calculate EST, EFT, LST, LFT and total float. Okay, na? So EST, EFT 1 to 2. Activity 1 to 2. Earliest start time and latest finish time. Okay, na? 0 and 20. 0 and 20. Earliest finish time is 0 plus 20 is 20. 20 minus 20 is 0. The way we did before, exactly the same way. And the total float is this minus this or this minus this. Comes out to be 0. Comes out to be 0, correct? Na? In one go, I am calculating everything. Now, activity 1, 2, 3. Earliest start time 0. Latest finish time 30. 0 and 30. Activity consumes 25 unit time. So 0 plus 25 is 25. And 30 minus 25 is 5. Correct? And the total float is this minus this or this minus this. Total float is 5 unit. Correct? Now activity 2 to 3. 20 and 30. 20 and 30. Tij is 10. So this is 30. 30 minus 10, 20. Now total float will be 0 here in this case. Correct? Na? In the last problem, I was extremely slow. I am applying the same procedure here. Activity 2 to 4. 20 and 35. 20 and 35. Tij is 12. 12 plus 20, 32. 35 minus 12. Correct? So here, total float will be 3. What I recommend to all of you that you have pen and paper and you do on your own, just verify the answer, whatever I have given to you. 3 to 4, activity 3 to 4, 3 to 4, 30 and 35. 30 and 35. Tij is 5, 35, 30. So here also 0. Now 4 to 5, 4 to 5, 30 and 45. Tij is 10, so this becomes 40 and this becomes 35. 35 minus 30 is a 5. 4 to 6, 35 and 47. No, 4 to 5. 4 to 5, 10, no, sorry, it's a 10. We made a mistake. Tij is 10. So 40 and 35. And it is 35. Here is 35. And 45. 4 to 5, na? 4 to 5 is 35 and 45. And Tij is 10, 45, 35, and this is 0. Now 4 to 6. 35 and 47. Tij is 5. So this becomes 40 and this becomes 42. 42 minus 35 is 7. 7 is total float here. 5 to 7. 45 and 55. Tij is 10. So this becomes 55. 45 minus 45, total float is 0. 6 to 7. Now it's a 40 and 55. Tij is 8, 48 and 55 minus 8 is 47. So it's 7. So I will match it with whatever I have in my book. Total float 503 00707, correct. So it's the correct one. So the activities having 0 total float, activities having 0 total float are the critical activities. So these are the critical activities. Critical path is 1, 2, 3, 4, 5, 7. It is a critical path. 1, 2, 3, 5, 7 is a critical path. And the project completion time is 55 days. Project completion time is a 55 days. And the normal project cost, if you add everything, this summation, that becomes the normal project cost, that is called rupees 3,600. If you add everything, becomes 3,600. So normal project cost normal project cost is rupees 3,600. Okay, normal project cost is 3,600 rupees. It can be completed in 55 days. And the critical path is 1, 2, 3, 4, 5, 7. That is our critical path. Up to this point, I hope everybody is okay. Up to this point, I hope everybody is okay. Now, what the question says? What will be the cost of total project when its duration has to be decreased by 4 days? 10 days I will take up later. First of all, what will happen when the project duration is decreased by 4 days? Okay. So case 1. I want to decrease the project duration. I want to decrease the project duration by 4 days. So that is my first problem. To decrease the now here very carefully. For next 10 minutes, you have to see very, very carefully. To decrease the project duration, we need to crash the critical activities. Because it is the critical activities, that decides the project duration. So only critical activity needs to be crashed. There was one question in GATE long back. Question was, a project is having 3 alternate paths, 7, 5, 6, 6, 6, 6, 4, 8. 1, 2, 3, 4, 5. Now, all the 3 paths are critical. 7 plus 5, 12, 12 and 12. All the paths are critical. Question was, if I want to decrease the project duration by 1 day, how many activities I need to crash? See, all paths are critical. So if you crash any activity on this path, still there will not be any decrease in the project duration, because these 2 paths are still critical. So crashing the activity on one path has no meaning, unnecessary wastage of money, and there is no benefit. So the project duration will decrease only when you crash one activity on each path. Simultaneously, you have to crash at least one activity on each path. So how many activities needs to be crashed? 3. Because there are 3 critical paths. If there are 2 critical paths, if I want to decrease the project duration, on each path I have to crash one activity. Then only the project duration will decrease. Because if you crash one activity, still the remaining paths are critical. So one activity on each path needs to be crashed. Now coming back to this problem. So one thing is decided to decrease the project duration. I need to crash critical activities only. Non-critical activity crashing, there is no benefit. Unnecessary cost will increase and project duration will not decrease. So in engineering, I am always thinking of economy. So I will now see what I am going to say. Very, very carefully here what I am going to say. I will choose that critical activity to crash first. Where minimum money is spent from my pocket. A critical activity needs to be crashed to decrease the project duration. But which critical activity I will crash first? The activity in which minimum money is spent from my pocket. And what is that parameter that decides the minimum money is spent per crash? Cost slope. Cost slope is nothing but crash cost minus normal cost divided by normal time minus crash time. So for example here 720 minus 600 divided by 20 minus 7 comes out to be 40. So what is the meaning? Per crash 40. Suppose if I am crashing activity 1 to 2, per crash I have to spend 40 rupees. Per crash I have to spend 40 rupees. So calculate the cost slope of each and every activity. Just 2 minutes I will give you some break so that you can calculate the cost slope of each and every activity. Activity 1 to 3 is machine specific, so 0 cost slope. So these are the cost slopes. These are the cost slope of each and every activity. Cost slope of each and every activity. So now I want to decrease the project duration by 4 days. So I will select the activities having minimum cost slope. So those activities are 1 to 2 and 3 to 4. 1 to 2 and 3 to 4. Let us see whether these are critical activities. Yeah, both are critical activities. Because their total floats are 0, so both are critical activities. Activity 1 to 2 can be crushed by 3 days. And activity 3 to 4 also can be crushed by 3 days. So what are the activities I am going to crush? 1 to 2 and 3 to 4. 1 to 2 and 3 to 4. These are the activities I am going to crash. Once again, you should have your head cool. Whatever I am going to speak, it is very, very, very important stuff. You should have your head cool and hear carefully. Activity 2 can be crushed by 3 days. Activity 1 can be crushed by 3 days. Before crashing any activity, we have to see the total float available on the parallel branch. Before crashing any activity, we have to see the total float available on the parallel branch. So 1 to 3 and 2 to 4. 1 to 3. 1 to 3, the total float is 5. 1 to 3, the total float is 5. And 2 to 4, the total float is 3. 2 to 4, total float is 3. See now why I am saying? By crashing any activity, hear very, very carefully what I am saying. By crashing any activity, I am eating up. By crashing any activity, I am eating up the total float on the parallel branch. I am eating up the total float on the parallel branch. For example, if you crash this activity by 3 days, this total float will become 0 and this activity will also become critical. Let us say, you have to be very, very careful. Suppose the total float available here is 2. Total float available on the activity 2 to 4 is 2. And if you crash this activity by 3 days, you know what will happen? This branch will become critical and this will become non-critical. There is no benefit. This branch will become critical and this will become non-critical. So unnecessary you are spending money. You are spending money without decreasing the project duration. So that is the reason I told you that before crashing any activity, see the total float available on the parallel branch. Suppose if I crash by 1 day, total float will become 2. If I crash by 2 days, total float will become 1. If I crash by 3 days, total float will become 0. By crashing any activity, I am eating up the total float available on the parallel branch. So, suppose it's a conventional and the regular class, I have gone too much deep into it. But because it's a one-shot crash series and gate is next door, you crash the activity maximum You crash any critical activity maximum to the point of how much total float available on the parallel branch. How much total float available on the parallel branch. So now I want to decrease the project duration by 4 days. So 3 to 4 you crash activity 3 to 4 you crash by 3 days, and activity 1 to 2 you crash by 1 day, because both cost slope is same. Okay, na? So our increase in cost will be same, and activity 1 to 2 activity 1 to 2 you crash by 1 day. After each crash you make the precedence diagram again. After each crash you make the precedence diagram once again. 5, 6, 7. And write the modified times. So this activity you have crashed by 1 day, so it will be 19. There is no change here. 25. This activity is crashed by 3 days, so this will become 2. 25, 2. 12, 10, 10. 12, 10, 10. This activity I have crashed by 3 days. This activity I have crashed by 1 day. 5 and 8. Okay. After each crash, you make the precedence diagram again. Zero forward pass, 19. 19 is 29. 29 to 31. 19 plus 12, 31. So there are alternate critical path. 41, 31 plus 36. 51, 51, 41 minus 8. 43, 31, 29, 19, 0. So this path is also critical now. Previously this path was critical. Now the total float here is also 0. So this path is also critical now. This path is also critical. Okay. So how much will be the total cost? Total cost. Normal cost was 3600 plus cost slope is 40, and I have done 4 unit crashing. 40 into 4 unit crashing. So 3760. That will be the cost of crashing. Now the project completion time is 51 days and the cost is 3760. Project completion time is 51 days and the cost is 3160. That is the answer of your First problem. That is the answer of your first problem. Okay. Now, what is the second problem? I have to crash by 10 days. I have to crash by 10 days. So now case 2, I am crashing for 10 days. I am crashing the network for 10 days. Total 10 days, okay na? Activity 1 to 2 can be crashed by 3 days. Activity 3 to 4 can be crashed by 3 days. And the total float here is 5. So I can crash this activity by 3 days. Up to 5 days we can crash, but 5 days I cannot crash as per data. Maximum 3 days I can crash. Availability of total float is 5. So if I crash this network by 3 days, the total float will be 2 now. So activity 1 to 2, activity 1 to 2, I will crash by 3 days. Crash by 3 days. Activity 3 to 4, I will crash by 3 days. 3 to 4 activity crash by 3 days. 4 more days I have to crash. So I will go for next higher cost slope 50. 50 na? 50 is for 2 to 4. 50 is for 2 to 4. Now this activity is also critical now. If I crash by 3 days, this activity is now critical. Correct na? So I will not crash this activity, bhai. If there are 2 parallel branches, both are critical. If there are 2 parallel branches, both are critical. To decrease the project duration on each branch, I have to crash. For example, I have to crash here, and this cannot be crashed, so I have to crash this 2 to 3. So 2 to 3 simultaneously, I have to crash this and this. It means my cost will be 120 rupees per crash. Very expensive. Very expensive. So I will go for next higher crash cost. See, if it is a live class now, we will have enjoyed like anything. And I would have been also dead slow. And if you have any confusion, you can remind and see. Okay, na? And of course, I am available for any discussion. So I will go for next higher. Next higher are 60, 60, 60. 4 to 5, 5 to 7, 6 to 7. 4 to 5, 5 to 7, 6 to 7 is not critical, so I will not use it. So 4 to 5 and 5 to 7. See the total float on 4 to 6. 4 to 6, 6 to 7 is 7 total float. Total float is 7. Here I am telling you another funda. So this particular crashing, I think you have to see 1 or 2 times. Here I am telling you another funda. This is one branch. Hear very carefully on the screen. See a screen and hear very carefully. This is one branch. And on that branch, there are two activities. On that branch, there are two activities, 4 to 6, 6 to 7. For both, total float is same. Always remember, total floats are for branch, not for individual activities. On the branch, whatever activities are having, all the activities will have same float. Doesn't mean that here total float will be different and here total float will be different. It's one branch. For both the activities, total float will be same. So if I'm crashing any activity on this branch, I'm eating up the total float of the entire branch. For example, I have to crash by 4 days. Activity 4 to 5 can be crashed 5 days. So activity 4 to 5, I will crash by 4 days. Because maximum it can be crashed by 5 days. But my duration has to decrease by 10 days. Na? So now again make the precedence diagram. Again construct the precedence diagram. Again construct the precedence diagram. Now write the times after crashing. After second crashing, write the time. This activity is crashed 2 more days. Previously 1 day. So 17, 25, 10. There is no crashing here. 12 and 2. 12 and 2. Now activity 4 to 5, I am crashing by 4 days. So in place of 10 will become 6. 10. 5 and 8. Do the forward and backward pass. Do the forward and backward pass. Uh, 0, 17, 27, 29, plus 6, 35, 34, 45, 45 and 35, minus 8, 37, 29, 27, 17 and 0. Now critical activities. This is a critical path. This is also critical path. Previously total float was 7 for both the cases. If I crash this activity by 4 days, the total float left out will be 3 days. Total float left out will be 3 days. This particular question I ask you, I will request you to see again. You again calculate the total float, you will find out that 3 here, 3 here. Once again, total float is for all the activities on the branch. On the branch, whatever activities are there, total float will be same. Total float will be same. And if we are crashing any activity on the parallel branch, I am eating up the total float of the entire branch, not the individual activity. Not the individual activity. So now here the total cost will be 3600 is the normal cost. Three unit I have crashed here, 3 unit I have crashed here, 6 unit. And how much was the crash cost per crash? 40. 4 unit I have crashed activity 4 to 5. And activity 4 to 5 crash per unit is 60. So that is the total cost. Project duration is 45 days. And that is the cost. So by crashing, we are decreasing the project duration and we are increasing the project cost. We have to sacrifice somewhere. We crash activities on the critical path. But while crashing the activity on the critical path, we have to see the total float available on the parallel branch. I cannot crash any critical activity more than the total float available on the parallel branch. Because the parallel branch will become critical and existing branch will become non-critical. Next point, if there are multiple parallel critical path, like this, to decrease the project duration, I need to crash one activity on each critical path. To decrease the project duration, I need to crash one activity on each path. So that approximately for 1 hour, I have discussed crashing. And it is very, very important. I request all of you to go through this 1 hour section again. Because these one-shot lectures is totally packed. Really, you would have enjoyed if it is a live class or let us say offline class that I used to teach. Crashing, generally I spend 2.5 hours just on the crashing in the normal class. But here, one shot, everything is packed. It's a nectar. Packed everything in every sentence. So maybe you have to see this lecture again. Okay. So that was your crashing. So I discussed with you critical path method is a deterministic model. Where activity times are well defined. But in every activity, there are probabilities. Next is program evaluation review technique. In part, both activity and the project completion time follows a probability distribution. Both the activity and the project completion time follows a probability distribution. Activity time follows a beta distribution. And the project completion follows a normal distribution. Project completion time follows a normal distribution like this, x bar. So in the forward and backward pass, whatever value that was coming in the last box, that is x bar. Mean. So from here to X bar, it's a 50% area. So in the PERT, you know what I will say? Suppose same thing appears in the PERT, you know what I will say? There is a 50% probability that project will be completed in 45 days. I will say like that. There is a 50% probability that my project will be completed in the 45 days. Project completion time follows a normal distribution. And activity time follows a beta distribution. Beta distribution is like this. Probability and the parameter, the beta distribution. Now, why beta distribution is followed? Why beta distribution is followed for activity times? Because of two reasons. Number one, it's a unimodal. Unimodal means depends upon the data, its shape doesn't change. Its shape doesn't change. Second reason is beta distribution is having two intercept on x-axis. Beta distribution is having two intercept on the x-axis, and this corresponds to pessimistic time and the optimistic time. Pessimistic time, I will explain these things. Pessimistic time and optimistic time. And wherever there is a peak, that is called mod, na? Mod corresponds to peak value, and this is called most likely time. This is called most likely. This is called pessimistic, and this is called optimistic time. Now I will explain to you how the probabilities sink into activities. Let us take the same example of construction of this building. One activity is, let us say I am recording this lecture in Hyderabad. Activity is truck goes from Hyderabad and approximately 60 kilometers from here there is a district called Sangareddy, and there is a Manjira river. So there a lot of sand is there, okay na? So truck goes from Hyderabad, take the sand from the river and brings back to Hyderabad, let us say Kukatpalli area. That's an activity. Activity means truck start from Hyderabad, goes to Sangareddy, pick the sand and comes back here. Now, for completion of this activity, you can expect many troubles. You can expect many troubles. Trouble number one, truck is going. It got punctured. Trouble is there. Trouble number two, truck is going. It caught into traffic. Let us say Kukatpalli, Panjakutta, and then Sangareddy. 3-4 times truck caught into traffic, and multiple times puncture may also happen. Problem number three, there was one traffic police wala, and he said, oh, stop, where are you going? There will be challan. So traffic cop stopped the truck. Okay, there are many problems this activity may face. Now point number one, suppose the truck goes and without any problem comes back. The time spent is called optimistic time. Means no problem is encountered. How much time is taken by the activity to complete? Optimistic time. But suppose when the truck starts, there was a traffic jam. There was puncture few times. Traffic cop also stopped the truck. Like we say that in the morning, whose face you have seen that you are getting one difficulty over another. So same thing happens. You have seen the face of somebody. So one difficulty after another. All the difficulty you can think of appeared on the way of this activity. Still the activity can be finished in certain time period. That is called pessimistic time. Pessimistic time, optimistic time. But you know, when the truck goes and comes back, one or two difficulty you may face. Only once he caught into traffic, only one time puncture. So most likely the truck will arrive this time period. So there are three times: optimistic time, pessimistic time, and the most likely time. Just let me know in the chat box that whether you like this example, because generally teachers gives that definition and goes away with it. I am giving you an example. Okay, na? Very good example. Okay. So here we calculate the mean time. Mean of beta distribution is here. Mean divides the distribution area into two equal halves. Mean divides the distribution area into two equal halves, and it's nothing but optimistic time plus pessimistic time plus 4 times the most likely time divided by 6. This is the mean of each and every activity, and the standard deviation is 1 by 6 pessimistic time minus optimistic time. Standard deviation of activity and the mean time. Okay, so project completion time follows a normal distribution. So these things I will explain to you with the help of an example. These things I will explain to you with the help of an example. This is the example. What is the probability that the project will be completed in 14 days? What is the probability that the project will be completed in 21 days? There are two examples here. So for activity, optimistic time, pessimistic time, and the most likely times are given to you. Okay, na? So first of all, because the nodal positions are given to you, these are the nodal positions. Nodal positions are given to you. So it's easy to construct the precedence diagram. And similar to the critical path method, on each and every activity we are writing some duration. In part we will write Tm. In part we will write Tm. Not optimistic time, not pessimistic time, and not the most likely time. We will write Tm. So first of all, calculate the mean time. All the activities, calculate the mean time. Optimistic time plus pessimistic time plus 4 times the most likely time divided by 6. So it is 2. So giving you 1 minute, can you write the mean time of all the activities? Write the mean time of all the activities. I will change the color so that it is visible to all of you. It's a 2. What is the formula? Formula is this one: optimistic time plus pessimistic time plus 4 most likely time divided by 6. Standard deviation is 1 by 6 Tp minus T naught. I want you to calculate everything, and it is 2, 4, 3, 1, 6, 5, 7. Similarly, calculate the standard deviation. Standard deviation, pessimistic time minus optimistic time divided by 6. Calculate. Please calculate the standard deviation of all the activities and hence the variance. Variance is square of standard deviation. Variance is square of standard deviation. No, it's standard deviation. Calculate the standard deviation and variance of each and every activity. So after constructing precedence diagram, I will draw the mean time only. So let us construct the precedence diagram. Activity 1 to 2, 1 to 3. One to two is 2, and 1 to 3 is 4, and 1 to 4 and 1 to 4 is 3 unit time. 2 to 5, 3 to 5. 2 to 5, 3 to 5. 2 to 5, 1, 3 to 5, 6. 4 to 6, and the 5 to 6. 4 to 6, 5 unit, and 5 to 6 is a 7 unit. This is the precedence diagram. Please check whether everything is okay. So in part, these times are the mean times. Rest of the calculation procedure remains similar to CPM. Rest of the procedure remains similar to CPM. Do the boxing at each and every node. Boxing at each and every node. Do the forward and the backward pass. 0, 2, 4, 3. 2 plus 1, 3. 4 plus 6, 10. 3 plus 5, 8. 10 plus 7, 17. 17 minus 10. 17 minus 5 is 12. 10 minus 1 is 9. 10 minus 6 is 4 and 0. This is the forward and the backward pass. Same EST 1:2. EST 2 and 9, 0, 0 and 9, 0 and 9. Mean time is 2. So 0 plus 2 is 2. 9 minus 2 is 7. And that's in critical path method we call it total float. Here we call it slack. Thing is same. There we call it total float. Here we call it total slack. So seven minus 0 is 7. Total slack is 7. Now 1, 2, 3. 1, 2, 3. Earliest start time is 0. Latest finish time is 4. 0 and 4. 0 and 4. Okay. Here actually we have done earliest finish time will be 2 and here will be 7 because we have reversed it actually. Okay, na? So now mean time is 4. 0 plus 4 is 4. 4 minus 4 is 0. So total float is 0 here. Correct? 1 to 4. Earliest start time is 0. Latest finish time is 12. 0 and 12. 0 and 12. Mean time is 3. So 0 plus 3 is 3. 12 minus 3 is 9. So total float is 9 here. 9 minus 0. LST minus EST is the total float now. Now 2 to 5. Earliest start time, latest finish time. 2 and 10. 2 and 10. Mean time is 1. So 2 plus 1, 3. 10 minus 1, 9. 9 minus 2, 7 is the total slack. In CPM we call it total float and here we call it total slack. 3 to 5 now. 4 and 10. 4 and 10. Mean time is 1. So 4 plus 1, 5. No, mean time is 6. Sorry. Mean time is 6. So 4 plus 6, 10. 10 minus 6 is 4. 4 minus 4, total slack is 0. 4 to 6. 4 to 6. Earliest start time 3. Latest finish time is 17. 3 and 17. Mean time is 5. So 5 plus 3, 8. 17 minus 5 is 12. 12 minus 3, 9. Last one also you do. 5 to 6. 5 to 6 is 10 and 17. Mean time is 7. So this is 17, 10. Total slack is 0. Critical activity, critical path will have 0 slack. Critical path will have 0 slack. So this is the critical path. 1, 3, 5, 6 is critical path. Pretty much it's same. Pretty much it is same. Pretty much it is same. As I told you, project completion time follows a normal distribution. X bar will be 17. Now, what will be the standard deviation of this normal distribution? This standard deviation will be under root summation of variance of critical path. Variance of critical path. So what is the critical path? 1 2 3, 3 2 5, 5 2 6. 1 2 3, 3 2 5, 5 2 6. Summation of variance of critical path. So how much is the summation of variance? 1 plus 4 plus 4. 1 plus 4 plus 4 under root 9 is becomes 3. So standard deviation is 3. Okay. So now what is the first question? What is the probability that the project will be completed in 14 days? So 14 days project completion probability. X bar is nothing but 17. X is going in this side. Probability of X is on the y axis. X is equals to 14 is here. So technically I need this area from minus infinity to 14 px dx. I want this answer. So how exactly we calculate? We calculate a parameter z. It is nothing but x minus x bar divided by sigma. So I project this. I am operating the normal distribution now. Okay, now 14 minus 17 divided by 3 comes out to be minus 1. So corresponding to z minus 1, if there is a calculator, you can calculate this thing in calculator. Otherwise, there are normal distribution tables that are given. And if you see the tables, normal distribution table, these values comes out to be 0.1587. So this area is 15.87%. So 15.87% probability is there. 15.87% probability is there that the project can be completed in 14 days. That the project can be completed in 14 days. Now what about the 17? 17 days probability. Mean is 17. Okay. And my question was 21 days. 21 days. 21 days completion probability. So x is equals to 21 appears here. We have to calculate this area from minus infinity to 21 px dx. So z is equals to x minus x bar divided by sigma. 21 minus 17 divided by 3 comes out to be plus 1. Previously z was minus 1. Now it's a plus 1. And this area is 0.9082. You have to see the normal distribution table, or calculator also normal distribution table is there. Calculator also normal distribution table is there. So 0.9082 means there is a 90.82% probability. There is a 90.82% probability that the project can be completed in 21 days. So in part, activity time follows a beta distribution and project completion time follows a normal distribution. In the part, we will never say that 100% project will be completed. We always attach probability. But pretty much procedure of doing that thing is almost same. Slight difference is there in part. So that's what was the discussion on the project management. Once again, I request you to see the crashing and some important topics 2 times so that everything goes directly to your mind. Thank you very much. All the best.